So we took a quiz and we didn't have time to go over it in class. So I'd like to go ahead and cover the solutions to these so that you're prepared for your test tomorrow. On the screen, you'll have the times at which I start the various explanations of each particular question. So you can fast forward through to the point that you need, or you can watch the whole video. Beginning with number 1, it says write an equivalent logarithmic equation for e cubed is equal to 2x. There are faster ways, but I'm going to show you the step-by-step method. First thing I can do is I can take the natural log of both sides. So I have the natural log of e cubed equal to the natural log of 2x. Then using my power property, I can bring the 3 out in front of the natural log. And the natural log of e, this portion right here, is equal to 1. Therefore, my final answer can simply be 3 is equal to the natural log of 2x. Number 2, you used a calculator, so you just had to take e to the 4.5 power, and when you do that, you should get 90.017. For number 3, again, just a calculator problem. You type in the natural log of 17.2 and you get 2.845 as your answer. Question number 4. A substance decays according to the equation of y equals a e to the negative 0.025 t. If t is in minutes, find the half-life of the substance. So I'm going to begin by saying that y is equal to 1/2. So half of my substance is equal to my a value, which is 1. It's what I started out with, so 100% or 1 gram. So I can just leave the 1 off, and that gives me e to the negative 0.025 t power. To solve, I take the natural log of both sides, so I have the natural log of 1/2, or 0.5 as a decimal, is equal to the natural log of e to my exponent here, but that's going to bring my exponent out, so it's going to be simply negative 0.025 t. Dividing both sides by the negative 0.025, that gives me a value of 27.7. So the answer is 27.7 minutes. Number 5. 1925, the population of a city was 90,000. If its population increased to 648,169 in 2020, what equation could be used to estimate the population in any given year since 1925? There are 2 ways to solve this problem. I'm going to start by using a base e. I'll work it out both ways. I have 2 values. One value is year 0, which we're going to equate to the 1925 number. We had a population of 90,000. My second bit of information is in 2020. Well, 2020 would be 95 years after 1925. So in 2020, we had a population of 648,169. Now I can use those 2 points. If I need to solve for my initial value was 90. So using the basic equation of y is equal to a e to the kt power. If I start by saying my initial value was 90,000, my ending value in 2020 was 648,169. I don't know what my k value is, but my t value in this particular year was 95 years later. Now, to solve for my k, if I divide both sides by my 90,000, that gives me 7.2018. And so that is equal to e to the k95 power. Taking the natural log of both sides, so the natural log of 7.2018 is going to be equal to 95k. So k is going to be equal to the natural log of the 7.2 number divided by 92, which gives me 0.0208. So my final equation is going to be y equals 90,000 e to the 0.0208 t power. The second way to work this one out is using the basic form of y equals a b to the x. My initial amount is going to be the same value for my a, which is that 90,000. And my final amount is going to be the 648,169. It's going to be b to the x power. In this particular case, the x value is going to be 95. Again, 95 years later would put me at year 2020, which is where I got the 648,000 number. Taking the 648,169 and dividing by the 90,000, that gives me a value of 7.2018 again. And this time that's equal to b to the 95th power. Now I need to take the 95th root of that number. When I do that, I get 1.021 is equal to b. And so my final equation becomes y is equal to 90,000 times 1.021 to the t power. Number 6. A type of bacteria is increased in population based on the formula. What is the maximum population? The maximum population is going to be the number right on top. For number 7, according to the formula, when t is in hours, when will the population reach 65,000? So I'm going to start off by setting this equal to my 65,000. Next, I'm going to multiply by my denominator and divide by the 65,000. So that's going to be the 1 plus 2e to the negative 0.28 t power. That's going to be equal to the 250,000 divided by the 65,000. Now if I take 250,000 and I divide by 65,000, that gives me a value of 3.846. If I subtract 1 from both sides, that's going to give me 2e to the negative 0.28 t power equal to 2.846. Dividing both sides by 2 gives me e to the negative 0.28 t power equal to 1.423. Now I can take the natural log of both sides. It's going to give me a negative 0.28t equal to the natural log of that number, which is 0.3528. And then dividing by the negative 0.28 gives me a time that is equal to negative 1.26. So approximately 1.26 hours prior was when the population was 65,000.